Hello everyone, welcome back to my YouTube channel Crack CSA Exam with Ease. I hope you have seen my previous video in which I have covered 30 questions of CSA Physics 2026 exam. In this video we are going to cover the rest of the questions. Now move to question number 31. A straight wire with the length L is equal to 0.5 meter and a current I is equal to 2 ampere is placed in a uniform magnetic field with a magnetic induction B is equal to zero point 0.4 Tesla. The angle between the direction of magnetic field and the direction of current in the wire is 30 degree. The ampere force acting on the wire. Here magnetic field is making angle 30 degree with the current carrying wire, and I is given as 2 ampere. Magnetic field is given as zero point 0.4 Tesla and theta is 30 degree. Length of wire is given as 0.5 meter. So we will calculate force is equal to I into L cross B, and which is equal to I into L into B sine theta. We will put the value of I, that is 2, length, that is 0.5, B, that is 0.4 into sine 30 degree. When we solve this, we will get force is equal to 0.2 Newton. So option B is correct. Question number 32. In a straight uniform field with a magnetic induction of B zero point 0.8 Tesla, a rectangular coil has an area S is equal to 0.5 meter square. An angle between normal direction of coil plane and the direction of magnetic field is 60 degree. Therefore, the magnitude of magnetic flux passing through the coil is. Here coil is drawn with the white marker and the normal vector is making angle of 60 degree with the magnetic field. Here magnetic field is given as 0.8 Tesla, area is given as 0.5 meter square, and theta is given as 60 degree. So the magnetic flux passing through the given area is B dot A, which is equal to BA cos theta. We will put the value of B, that is 0.8, and area, that is 0.5, into cos 60 degree, which is equal to 0.2 Tesla. So option C is correct. Question number 32. As shown in figure, on the right side of a long straight wire with the current I flowing in the direction indicated, a rectangular metal wire frame ABCD is fixed. By adjusting the current I, the magnetic induction at each point in space increases uniformly over the time. Then here the current I is flowing through the conductor and the magnetic field produced by this conductor is increasing. So we will use right hand thumb rule to find the direction of magnetic field, which is pointing towards the paper, which is shown with the cross sign. Since magnetic field is increases with the time, so according to Lenz's law, the induced current will produce such that it opposes the increase of magnetic field. Therefore, it must point out of the page, which is anti-clockwise direction, that is ADCBA. Here EMF is equal to, we know that EMF is d phi by dt, which is equal to A into dB by dt. And here change in magnetic field is constant, so EMF will also be constant, and we know that current I is equal to E by R, so this value will also be constant. So option D will be incorrect, and option A is also incorrect. Here the direction is given as A B C D A, and when the frame is moving, here the frame experiences an ampere force horizontally towards the right direction. Since the AB rod is passed towards this conductor, so the magnetic field at this point will be more as compared to the magnetic field at through the line BC. So we know that force is directly proportional to magnetic field. That is why the force experienced by AD wire will be greater than the force experienced by BC wire. So the wire will move towards the right. Next, we know that force is equal to I into L into B. If magnetic field is increases, so the force on AD wire will also increase. It will not be constant. So option D is wrong. So the answer of this question will be option C. Now move to question number 34. As shown in the figure, there is an electric field in the space with the 2 points A and B. Which of the following statement is correct? Here the two regions are shown, region 1 and region 2. In region 1, the electric field lines are crowded, so here the strength of electric field is higher as compared to region 2, where the electric field are far from each other. So option A is correct. Question number 35. As shown in the figure, the cross section of glass cylinder is semicircular. A monochromatic beam travels through the cylinder towards the center of the semicircle O at an incident angle of 30 degree. The reflected beam 1 and the refracted beam 2 produced are exactly perpendicular to each other. Therefore, refractive index of the glass is. We know that according to law of reflection, angle of incidence equal to angle of reflection. So here angle of incidence is given as alpha, or I have represented with the I, which is given as 30 degree. So angle of reflection will be equal to angle of incidence. So angle of reflection will becomes 30 degree. If you see the diagram, you will find that angle R plus 90 plus I dash is equal to 180 degree, and we will get the angle of refraction that will be equal to 60 degree. So according to Snell's law, we know that n1 sin alpha is equal to n2 sin r, where n1 is the refractive index of first medium. Here first medium is glass, and n2 is the refractive index of second medium, which is air. And then we will put the value of alpha, that is the angle of incidence, that is 30 degree, and angle of refraction, that is 60 degree, and we will find the value of refractive index of glass, and that will be equal to sin 60 divided by sin 30, which will be equal to root 3. So option A is correct. Question number 36. The trajectory of leaf falling from the air is shown in the figure. The velocity direction of the leaf at a positions A, B, C and D are indicated. The correct direction is. Here the path of the leaf is shown and different points are represented, which are giving the direction of velocity, and we know that the direction of velocity is tangent along the path. So this D is showing the correct diagram. So according to this, option A is correct. Question number 37. As shown in the figure, a student throws a basketball with the mass of m from height of h at an initial velocity of v, and the basketball just enters the basket with the height of h above the ground. Taking the ground as a zero potential energy surface, ignoring the air resistance, and let the magnitude of gravitational acceleration be g, the mechanical energy of the basketball entering the basket is. Since we know that gravitational force is a conservative force, so the total mechanical energy of the system will remain the same. And here the basketball is thrown with the velocity v, so its initial kinetic energy will be half mv square, and it is thrown from the height h, so its initial potential energy will be mgh. So this total energy, that is half mv square plus mgh, it will remains same throughout the motion. So option D is correct, that is half mv square plus mgh. Question number 38. A car with a mass of 2 tons and an engine with the power of 30 kilowatt travel at a constant velocity of 32 kilometer per hour on a level ground. The resistance experienced by the car while driving on that road surface is. Here mass is equal to 2 ton, that is 2000 kg, and power is 30 kilowatt, which is equal to 30 into 10 raised to power 3 watt. We will convert velocity, that is given in kilometer per hour, which is equal to 20 meter per second, and we know that power is equal to force into velocity. So force will be equal to power by velocity. We will put the value of power, that is 30 into 10 raised to power 3 divided by velocity, that is 20, and this will becomes 1.5 into 10 raised to power 3 Newton. So option C is correct. Question number 39. A ball is shown horizontally from a certain height at an initial velocity of v naught and it lands on a level ground. Then ball is thrown again at the same height horizontally at an initial velocity of 2v0. It lands on the same ground. Ignoring air resistance during the second throw of the ball, here the two situations are shown in the diagram. The ball is thrown with the initial velocity v0 from the height h in first case, and in second case the ball is thrown with the initial horizontal velocity with the 2v0 from the same height. So we will analyze the motion along x direction and in y direction separately. So initial velocity of ball along x direction is v0 in first case, and acceleration is along x direction is 0, and initial velocity along y direction is 0 and acceleration along y direction is minus g. And we know that according to second equation of motion, s is equal to ut plus half at square, and here we are seeing the motion along the y direction. So displacement will be equal to minus h, and initial velocity along y direction is 0. We will put the acceleration along y direction, that is minus g, and we will get the time is equal to root 2h by g. And similarly we can calculate the displacement of ball along the x direction, that is equal to ut plus half at square. This is along the x direction. Then we will put the value of initial velocity, that is given as v0, and time we have already calculated, that is 2 root of 2h by g. Acceleration along x direction is 0. So the displacement of ball along x direction is v0 into root 2h by g. Now the option says that the horizontal displacement becomes half of the original. Here the when we put the initial velocity to be 2v0, the displacement will becomes twice of the previous. So according to this, the option A is wrong. Here time taken to fall becomes half. Since time does not depends upon the initial velocity, so time will remain the same. So option B is incorrect. So according to this, option D is correct, that is the horizontal displacement become twice of the original. Question number 40. As shown in figure, if two objects A and B with equal mass are placed on a horizontal disk rotating uniformly around the vertical axis and two objects remain stationary relative to disk, then angular velocity at A is equal to angular velocity at B. Since the disk is moving with the same angular velocity omega, so angular velocity at point A will be same as angular velocity at point B. And the linear velocity, we know v is equal to r into omega. Since the radius of mass A is greater than the radius of mass B, so linear velocity of particle at A will be greater than the linear velocity of mass at B. So option A is correct. Question number 41. An object with a mass m falls freely from a rest, ignoring air resistance. The power delivered by the gravity on the object over the time t is. We know that average power is equal to work done by time, and work done is equal to change in kinetic energy. And kinetic energy is half mv square. We will get average power is equal to half mv square by t. And we can find the velocity of particle after time t, that is equal to acceleration into time, which is g into t. Then we will put the value of velocity in average power, and we will get half mg square into t. So option A is correct. Question number 42. As shown in the figure, a fixed U-shaped metallic rail ABCD with the load connected is placed in a uniform magnetic field perpendicular to the plane of rails. There is a metal rod that can slide freely on the rails. During the process in which the rod moves to the left, which of the following statement is correct? Since rod is moving towards the left direction, as the rod moves, the area will increase, or as area increases, the flux will also increase. So according to Lenz's law, the current will produce in such a direction, it decreases the magnetic field. So it will produce in anti-clockwise direction. So option A, there is a current flowing through segment AE. Since this segment is not closed, so there will be no current flowing through this AE wire. There is a current flowing through BC wire. According to Lenz's law, the current will produce in the direction FCBEF. So the current will flow through segment BC, and the flux passing through EBCF remains unchanged. No, the flux will increase as we move the rod towards the left direction, and the magnetic flux passing through EBCF decreases. No, since area is increasing, so magnetic flux will also increase. So according to this, option B is correct. Question number 43. As shown in the figure, two identical metal balls are fixed at points A and B with the charges plus Q and minus 5Q respectively. At point charge Q is fixed at point C. The magnitude of magnetic force acting on this charge is F1. It is given that AB is equal to BC if two charged metal balls are brought into contact and then returned, the force becomes F2. Thus F2 by F1 is Fa is the force acting on charge Q at point C, that will be equal to K into Q divided by distance square, that is 2r square, and Fp is the force acting on charge Q at C due to charge at B point, that is K into 5Q into Q divided by r square. So the net force acting on charge that is at point C will be equal to Fb minus Fa. When we solve this, it will become 19 by 4 kq divided by 4 r square. And when these two charges they are brought in contact, so the net charge will becomes plus q minus q divided by 2, that is minus 2q, and these two charges will brought back to the original position. So the net force acting on charge C will be, that is Fa plus Fb, which will be equal to kq into 2q divided by 2r square plus kq 2q divided by r square. And when we calculate the net force on charge q in this situation, it will become 10 by 4 kq divided by r square. And after this we will take the ratio of charge F2 by F1, that will become 10 by 19. So option C is correct. Question number 44. A basketball with a mass of 0.6 kg moves horizontally to the left at a speed of 2 meters per second. When it hits a hard wall, it bounces back horizontally to the right at a speed of 1 meter per second. If the ball is in contact with the wall for a 0.1 second, the average horizontal force exerted on the basketball by the wall is. Here mass of the ball is given as 0.6 kg, initial velocity of ball is 2 meter per second, final velocity is 1 meter per second, and time is given as 0.1 second. So the impulse is equal to change in momentum, that is final momentum minus initial momentum, which is equal to m into final velocity minus m into initial velocity. Then we will put the value of mass, that is 0.6, into final velocity, that is 1, minus initial velocity, that is minus 2, and when we solve this, it will become 1.8 kg meter per second. Now we know that impulse is equal to force times time, then force will be equal to impulse by time, which is equal to 1.8 divided by 0.1, and it will become 18 Newton. So option D is correct. Question number 45. As shown in the figure, four masses A, B, C, D with the masses 4m, 3m, 2m respectively are connected. If the wire between B and C is cut, the acceleration of B and C in that instant are. Here the figure is drawn, and forces are also shown with the pink marker. This is the net force that is acting on 4m and 3m, 2m and m. So the net force acting on 4m mass is, that is T is equal to T1 plus 4 mg, and next is the net force acting on 3m mass is T1 is equal to 3 mg plus T2, and net force acting on 2m mass is 2m plus T3, and the net force acting on mass m is T3 is equal to mg. So when we solve these equation, we will get T2 is equal to 3 mg, T1 is equal to 6 mg, and T is equal to 10 mg. But when the wire is cut between the masses B and C, the tension at point T2, that will become 0. So the force on mass B will become, that is T1 is equal to 3 mg, and so acceleration of this mass will be force by mass, that is 3 mg by 3m, which will be equal to g. And for mass C, the net force acting on this will become 2 mg plus T3, that is 2 mg plus mg, which is equal to 3 mg, and acceleration of mass m will be 3 mg divided by 2m, so it will become 1.5 g. So option C is correct. As shown in the figure, two ends of the parallel metal rails are connected with the resistor R. The wire AB can slide when it moves uniformly to the right, which statement is correct. It keep moving uniformly without force. As the wire is moving with the velocity v towards the right direction, so without external force, the force Fv would cause the wire to accelerate and eventually stops. That means there is a magnetic force which is opposite to the direction of the velocity. So it will deaccelerate the rod and eventually the rod will stop. And next is increasing R increases pulling force. We know that force is equal to B square L square V divided by R. If we increase the R, that is resistance, the force will decrease. So option B is wrong. A wire is subjected to tension and magnetic force. So when the wire is pulled towards the right direction, the magnetic force will come into play, and to maintain, which will help in maintaining the constant velocity. So this option is correct. And from option B, here, if we increase the force, the velocity will also increase, that is both are directly proportional. So option D is wrong. Now move to question number 47. Maximum deceleration is equal to 6 meter per second square. Speed is equal to 108 kilometer per hour. Reaction time is equal to 1.5 second. Minimum saved distance is. Here initial velocity is given as 108 kilometer per hour. So we will convert that to be in meter per second, which is equal to 30 meter per second, and time is given as 1.5 second. So the distance covered by the object will be initial velocity into time, which is 30 into 1.5, which is equal to 45 meter. And after braking, the distance traveled by the vehicle will be equal to, we will use the third equation of motion, that is v square minus u square is equal to 2as. We will put the initial velocity, that is 30. Since object is stopped at the end, so final velocity will be 0. Then we will put the value of acceleration, that is given as 6, and we will calculate the displacement of the object, that will come to be 75 meter. So the total saved distance covered by the object will be 45 plus 75, that is equal to sorry, that will be equal to 120 meter. So I hope you understand all these questions. I hope you like the video. uh, Stay consistent, keep practicing. Hope I will see you in the next video. Thank you for watching it.